Okay, everyone, today I'm going to talk about the anterior spinocerebellar tract, and here I have an illustration of the pathways of this tract. And this tract, guys, originates from the neurons located at the base of the posterior horn. Okay, we have here the anterior, the posterior horn, and will originate from the base of the posterior horn in the spinal cord. Primarily on the opposite side of the body. Now, this tract will carry proprioceptive information, which we can include here sensations related to body position, movement, and muscle tension. And the anterior cerebellar spinocerebellar tract, especially the fibers, ascend through the spinal cord, and eventually reach the cerebellar hemisphere via the superior cerebellar peduncle, okay, which is here. Now, let me just complete this illustration. So here we have the spinal cord. I'm gonna use different colors here just to distinguish the anterior, the fibers that are originated from this, the base of this posterior horn and the base of this posterior horn. Okay. Okay, let me just do this. Posterior, lateral, and anterior horn. Here we have the posterior spinocerebellar tract and the anterior spinocerebellar tract. Now I'm gonna write down here some relevant information. Okay, anterior spinocerebellar tract. Okay, anterior spinocerebellar tract. And guys, this is a sensory pathway. Okay, Hydrate, thank you. And from this pathway, actually, this pathway transmits proprioceptive information from the periphery of the body to the cerebellum. And it's important especially for coordination, motor coordination, to be specific, and it will also help providing feedback about limb position. Okay, and what I'm gonna do now, I'm gonna do this. Let me just use this pen here. Let me start with this one here, the superior cerebellar peduncle, and this one serves as the primary conduit for the anterior spinocerebellar tract fibers, because they will enter through this area, the cerebellum. And it's one of the three major cerebellar peduncles, and connects the cerebellum to the brainstem. Now, I'm gonna write here superior cerebellar, thank you, peduncle. And then, okay, superior cerebellar peduncle. Let me just use the blue color here to distinguish from the other structures that I will put here. Okay, we have the fibers to the cerebellar hemisphere, Okay, and these fibers will come from the same side. So we have here the base of the posterior horn. What I'm gonna do, I'm gonna mark like this. This is the base of the posterior horn, and the fibers, am I doing right? Yeah, I think. Okay, so let me just, okay. What I'm gonna do, I'm gonna do this thing here. Okay. I will change the color because otherwise will be hard to see. What? Looks like someone was about to join here. Decline. Okay, this is the posterior, the fibers of the cerebellar hemisphere, but are the fibers from the same side. And what I'm gonna do, I'm gonna use the red color because then you know that for the same side will be related with the red color. Okay, and what I can, okay, these fibers here will especially contribute to the integration of sensory information that is necessary for fine motor control and coordination. Now I'm gonna do these two here, and let me just use the pen here to, and one of the things that you will notice here is that these two fibers will pass through the superior cerebellar peduncle and will cross the midline of the spinal cord. I have to use a different color here because otherwise it will be hard to visualize. Maybe the yellow one. Okay. The yellow one. I'm gonna use yellow for both, because these are the fibers crossing the midline to reach the cerebellar hemisphere. Okay, what I can do here, I can, this one, the red one, fibers to the cerebellar hemisphere. Okay, it's important to remember that these fibers here will be on the same side. And this will cross fibers crossing the midline to reach the cerebellar hemisphere. Okay, and Okay, these fibers here will ensure that the cerebellum receives input from both sides of the body. Okay, and this will help with the balance and the motor function. Okay. This is the midline of the body, and for the midline of the body, I'm gonna use another color, maybe the orange one. Okay. So what is important to understand when injury or disease affect the anterior spinocerebellar tract, this will lead the patient to impaired proprioception. And what will happen is the patient might present difficulties with balance, coordination, and precise movements. And some of the conditions that will um, let's say might impact this pathway uh, are the multiple sclerosis, spinal cord injuries, and also degenerative diseases. And cerebellar dysfunction. Um, Understanding that the anterior spinocerebellar tract projects to the cerebellum, any disruption here, uh, especially in its function, will manifest as a cerebellar signs. What this means: ataxia, which is uncoordinated movements; dysmetria, inaccurate reaching; and tremors will be things that will manifest in this patient. Okay. I don't think that I have anything else to say about this structure. Right now it's just this. And I'm gonna use the yellow one. When I finish here, if you want to print the screen, feel free. So just to remind that this video is about the anterior spinocerebellar tract. Yeah. So if you want to print, you can print, and that's it. Guys, thank you so much for being here with me. I hope you enjoyed the video, and don't forget to share this content with other people, especially if they are if they work with health and science. And yeah, I hope to see you next time. So enjoy the day. Take care. Bye bye.